friends, today we will be discussing about the four fundamental forces of nature. The four fundamental forces of nature are gravity, electromagnetic force, nuclear force and weak force. Now these are the four fundamental forces that drive our universe. Now these are the forces that are responsible for the way our universe works. Now before discussing each individual forces in detail, what I want to do is I want to first give you a brief introduction to the concept of force. Now what do you mean by a force? Now what do you mean by a force? A force is a physical quantity because of which a body attains some acceleration. Now I am defining the force this way using Newton's second law. Now Newton's second law says that F is equal to ma. Now F is equal to ma is Newton's second law. Now we have discussed Newton's second law in detail in Newton's laws of motion. So how do you define a force? A force is a physical quantity that when applied on a body gives it an acceleration. So that is how I define forces. I could also define force as something because of which two bodies interact. Now whenever two bodies interact, what they are doing is they are actually interacting using a force. Now this I could infer from Newton's third law. What is Newton's third law? Newton's third law says that for every action there is an equal and opposite reaction. Okay, so that is what Newton's third law is. Now when you go into the details of Newton's third law, it is clear that an individual force cannot exist. A pair of forces always exist in nature. A mono force does not exist. A single individual force cannot exist. Two forces will always be there. Forces always come in pairs. A single force never comes. Okay, so you always have a pair of forces. So forces are responsible for interaction between particles, interaction between bodies. Okay, so you have to remember this point. Forces are responsible for interaction between any two things, be it atoms, molecules, be it planets, be it stars, be it galaxies. Now when two objects they interact, it is clear that there is some force responsible for this interaction. So forces are what? Forces are physical quantities that are responsible for interaction between two bodies. Now with this introduction, let us move forward. Let us first discuss the gravitational force. Now what do you mean by the gravitational force? Now gravitational force is a force that acts between two large bodies. When I have two large bodies like Earth and Moon, these two objects, that is Earth and Moon, they attract one another with a force. That force I will call it as a gravitational force. Now I need not take a large body like Earth and a large body like Moon. I can also take the gravitational force of me also. Okay, there is a gravitational force for every object. Every object has the ability to attract each and every other object in the universe. This is the famous Newton's law of gravitation. Now the Newton's gravitation theory says that each and every body has got some mass, and because it has some mass, what it does is it tries to attract each and every other body in the universe. So gravitational force, you have to remember, is an attractive force. It is the force that is responsible for the formation of the solar system. It is the force that is responsible for the formation of the galaxies. It is even the force that is responsible for the way our universe looks today. Okay, so a solar system, a simple solar system like ours, has a star in the middle, that is the sun, and there are these planets revolving around this star. Now how does this happen? This happens because the gravitational force of the sun attracts these planets towards it, and therefore they start to rotate. So gravitational force is responsible for the formation of the solar system and galaxies, and every other large object that remains in this universe is due to the gravitational force. Now Now when it comes to the field theory, now there is a theory called as the field theory. Now according to this field theory, how do you understand this gravitation? Now the field theory says that there is a particle exchange going on between these two masses. This point is a very important point. Now what I am saying is, two bodies interact. Now let us consider two bodies of masses m1 and m2. Now these two bodies, they interact with each other by exchange of a particle. These two bodies, they exchange a particle, that is m1 gives a particle to m2 and m2 gives a particle to m1. What is this particle? This particle is known as a graviton. This is a very important concept in field theory. Now according to field theory, two masses interact with one another because they exchange a particle. Now why does sun and earth interact with each other? How can I interact with the earth? Now earth always pulls me downwards. Now how does this interaction takes place? Okay, one answer to this question is that the particles, they always exchange the gravitons. Okay, now what are these gravitons? These are the fundamental particles. So these gravitons are particles that are exchanged between two masses. Now an interesting question could be, now it takes 8 minutes for the light from the sun to reach earth. Okay, so it takes around 8 minutes for the light from the sun to reach earth. Now the question is, if you consider our solar system and if suddenly somebody plucks the sun away, there is no sun now, what happens to the solar system? For around 8 minutes you will find that the solar system remains the same. From earth you could find that there is no change. For 8 minutes you will not observe any change. You might be thinking that once the sun is plucked away, there is no sun at the center of the solar system, everything will be destroyed, the earth would immediately move away, but that is not the case. The solar system will remain intact up to the earth for 8 minutes. Up to 8 minutes there will not be any change. Now this is a very important concept. Even if you remove the sun, there will not be any effect seen immediately from the surface of the earth. Why? Because the sun provides the gravitons to the earth and earth is providing gravitons to the sun. Now the gravitons, they move at the speed of light, that is 3 into 10 to the power of 8 meters per second. So the gravitons take 8 minutes to reach the earth. So the information that the sun is not there reaches the earth only after 8 minutes. So therefore up to 8 minutes we don't know what has happened. Okay, now Einstein also gave his famous theory of gravitation. Now it was not only Newton but Einstein also gave a gravitation theory. Now this gravitation theory is known as the general theory of relativity. You call this as the general theory of relativity. Now according to the general theory of relativity, the space is not different, time is not different. There is only one thing called as space-time. There is one thing called as space-time, and he calls this space-time as the fabric, and he calls this as the fabric. Okay, so this is a fabric. What do you mean by fabric? I have taken a picture here of the fabric. This is how Einstein imagined the space-time. It is actually a fabric. It is a thin membrane. The fabric could be called as a thin membrane, and within this thin membrane, what I am doing is, that is, you take a plain sheet, and if you place a heavy object at the center of the plain sheet, now imagine this as a plain sheet. Now I have placed a heavy object at the center of the plain sheet. Now what happens? Now at this point, if there is moon, now because there is a curvature here, the moon starts to fall towards the center of the earth. Okay, so this is how Einstein explained the gravity. He said that there is something called as space-time. There is something called as space-time, and this space-time is actually a fiber. It's actually a fabric. Okay, it's like a cloth, a thin cloth, and within this thin cloth, at the center of this thin cloth, if you have a heavy object like earth, then what happens to a smaller object like moon? Because there is a curvature, because there is a downward curvature, what happens? The moon starts to move towards the earth, but the moon does not fall towards the earth because it rotates around the earth. Okay, so this is how Einstein explained the gravitational forces. So Newton was the first person to have explained the gravitation. Now he could not explain why the moon always falls towards the earth. He did not know the reason for the moon falling towards the earth. He did not know what is the reason for the earth falling towards the sun. The reason was given by Einstein. So Einstein, using his famous theory of general theory of relativity, he said that this space-time is a fabric, and within this fabric, if you place a heavy object at the center, what happens? There is a curvature. The fabric gets curved, and because there is a curvature, the objects try to move towards the center of this curvature, that is towards the earth or towards the sun. Okay, so this is about gravitation. Now you have to remember that gravitational forces can work from a distance of few meters to an infinite distances. Okay, so the range of the gravitational forces is from a few meters to infinite. You could take thousands and millions of kilometers. Now what is the distance between sun and earth? The average distance between sun and earth is 149 million kilometers. Okay, it is actually 149 million. A million is 10 lakhs. So 1490 lakh kilometers. Okay, so 1490 lakh kilometers. So the sun is at a distance of 1490 lakh kilometers from the earth. Even though it is at that far away distance, the sun has the potential to make the earth revolve around the sun. So the distance is huge. 1419 lakh kilometers is a huge distance. Even at that huge distances, you find that the earth has to rotate around the sun. Now what is the distance between earth and moon? The distance between the earth and moon is simply 3 lakh kilometers. That is, for a light beam takes only 1 second, or to be accurate, 1.2 seconds to reach the moon from the surface of the earth. Okay, so it is 3 lakh kilometers. The moon is at a distance of 3 lakh kilometers from the earth. Even though it is at a distance of 3 lakh kilometers, you find that the moon has to revolve around the earth. Okay, so the gravitational forces, they work at huge distances. You could take the distances even at infinity. Even at infinity, what happens is you have this force that is pulling objects towards itself. Now there is a question. Now if moon revolves around the earth, then you find that earth revolves around the sun. Is there anything around which the sun has to revolve? Yes, the sun also revolves. The sun has an angular momentum about its own axis. It also has an angular momentum about something else. The sun moves around the center of the galaxy. So it is a very important concept. The sun has both kinds of momentum. It has the angular momentum about its own axis, that is, it has spin. It spins about its own axis. It also has a rotation about the galaxy also. It also revolves around the galaxy. Now does our galaxy revolve any other thing? Yes, it revolves around a bigger galaxy. So this thing goes on. Okay, so all these interactions, the interaction between the large objects, it takes place because of the gravitational force. Okay, so whenever you have large objects, what is the force that is making sure that these two large objects interact with each other? The answer is gravitational force. Okay, now let us look at another important force, which is the electromagnetic force. Now you know that what do you mean by an atom? Now the answer to an atom is, what do you mean by an atom? An atom is something that has a positive charge at the center. It has a negative electron revolving around the center. This is a simple hydrogen atom. A simple hydrogen atom has a positive charge at the center, and it also has a negative charge revolving around it. Now how do you form this atom? The atom is formed because of the electromagnetic force between the electron and the positive charge. Atom is formed because of the Coulombic forces. Now I need not use the term electromagnetic force. The simple answer is a Coulombic force. Coulombic force is an electric force. Okay, so how does a solar system get formed? A solar system gets formed because of the gravitational force. Now how does a simple atom get formed? A simple atom gets formed because of the electromagnetic force. Okay, now atoms get formed because of electromagnetic force, molecules get formed because of electromagnetic force, our body gets formed because of the electromagnetic forces. If there was no electromagnetic force, then a simple cell could not exist. Our body is made up of a multitude of cells, and each and every cell contains these individual atoms. Now if these individual atoms were unable to get formed, then our cell will also not get formed. Also, electromagnetic forces play a very basic role in our life. Okay, when I am talking now, there are actually signals from my brain. There are actually signals getting created in my brain, and these signals are actually being processed, and that is how I am talking to you. I am moving my hand. Now how can I move my hand? I can move my hand because a part of my brain generates an electric signal, and these electric signals are passed through the neural nerve cells to my hand, and my hand, that is how the brain controls my hand. I could simply say that the brain controls each and every part of your body using electrical signals. Now these electrical signals are actually transferred from brain to each and every part of your body using nerve cells. Okay, so nerve cells actually take this use this electrical energy to move the muscles. Okay, now I'm moving the muscles in my hand. This happens because of the nerve cells, and these nerve cells, they get signals in the form of electrical signals. Okay, so your heart, it pumps, it beats for around 70 times. Now this beating is actually also an electric thing. Okay, so that is why whenever somebody has an heart attack, that fellow is given an electric shock at that heart. He is given, there is actually a potential difference get created between the left and right part of your heart, and an electric signal is transferred. When an electric signal is transferred, the heart again starts to pump. Okay, so electromagnetic forces are very important forces. These are the fundamental forces that are responsible for the formation of atoms and molecules, and these molecules, they form amino acids, these amino acids, they form proteins, and these proteins, they form cells, and these cells, they form tissues, and these tissues, they form organs, and the organs, collection of the organs gives you a body. Okay, so electromagnetic forces play a very important role. Now what is the range of these electromagnetic forces? Now the range of the electromagnetic forces is actually from nanoscale to a few meters. Okay, so the range is from a nanoscale. What is the distance between this positive charge and the electron? It is actually 1 nanometer. Now what is a nano? A nano is of the order of 10 to the power of minus 9 meters. So 1 nano is 10 to the power of minus 9 meters. So it actually, the electric force starts from 10 to the power of minus 9 meters. It moves on to a few meters. Okay, so these are the electromagnetic forces. Now another question is, in how many forms do you get this electromagnetic force? The electromagnetic force comes in two forms. One is the attractive form, the other one is the repulsive form, which you all know very well. Now gravitation comes in only one form. It is the attraction only. In gravitation there is no repulsion. Now two objects, they do not repel each other. The two masses, they always attract each other. But when it comes to electromagnetic, there are two forms of force. One is the attractive force, the other one is the negative force. Okay, that is the repulsive force. Now, so it is clear that electromagnetic forces are charge dependent. Depending upon the charge what you have either a positive force, that is an attractive force, or else a repulsive force. If you have two protons, both are positive, they repel each other. If you have a proton and an electron, they are positive and a negative, therefore they attract each other. So they are spin dependent, they are charge dependent. Okay, now I have said that in gravitation, I have said that two bodies interact by exchanging gravitons. In the gravitational force arises because of the exchange of a particle called as graviton. Now in case of electromagnetic force, what is the exchange? Which particle is exchanged between the charges so that they interact with each other? The particle is known as a photon. Photon is nothing but light. Okay, so photons are the particles that are exchanged between charges. This is a very important point. So photons are the particles that are exchanged between the charges. Now because there is an exchange of photons between the charges, they interact. Okay, so that is how two particles interact. Now how can you say the two charges interact? What is the reason for both the charges to interact with each other? The reason is they exchange photons. Two masses interact because they exchange gravitons. Okay, so this is about electromagnetic force. Now the next force is nuclear force. Now remember, nuclear force is the strongest of the four forces. It is the strongest of the four forces. Now when it comes to electromagnetic force, it is very strong when compared to a gravitational force, but nuclear forces are strongest of the forces, strongest among all the four forces. So question could be asked, which among the following is the strongest forces? Okay, the four options could be electromagnetic, gravitation, weak force and nuclear force. So nuclear force is the strongest force, and you find that nuclear force is charge independent. Now what do you mean by charge independent? Now we said that an atom is formed by an electromagnetic force. Now how does a nucleus get formed? Now I have said that there is a positive nucleus here. Okay, if I take a larger atom, then you find that the nucleus has a large number of protons and neutrons. Now what do you mean by a nucleus? A nucleus is something that contains protons and neutrons. Okay, now how does proton and neutrons exist within such a small area? Okay, now you find that the diameter of a nucleus is about a femtometer, is of the order of femtometer. Now what do you mean by a femto? Nano means 10 to the power of minus 9. Femto means 10 to the power of minus 15 meters. Okay, femto is a very small unit, 10 to the power of minus 15 meters. Within that small distance, you have these charges, you have these protons and neutrons getting squeezed. So in order to keep two protons that are repelling each other at a place, you need a large amount of force, and that large amount of force is given by a nuclear force. Okay, we know that proton repel, but in a nucleus there are protons. When you take uranium, its mass number is 238. Okay, its mass number is 238. That means there are 238 number of protons and neutrons. So this collection gives you a uranium 238 atom. Now how can you have such a vast amount of positive charges and neutral charges at a particular point? The answer is a nuclear force. Okay, so now the nuclear force works in the range of femtometers. Now if the distance r between two particles is greater than 10 to the power of minus 14 meters. Okay, if the distance between two particles is greater than 10 to the power minus 14 meters, then there is no nuclear force. If the r is less than 10 to the power of minus 14 meters, then what happens? Nuclear force kicks in. Now nuclear force is the dominant force. R greater than 10 to the power minus 14, electromagnetic is dominant. R less than 10 to the power minus 14, nuclear force is dominant. So therefore within the nucleus there are no Coulombic forces. Within the nucleus there are only nuclear forces, and these nuclear forces, they are charge independent. They do not depend upon the charge. It does not depend on the charge. That means a proton and a neutron interact with the same amount of force as a proton and a proton. If proton have an interactive force of F, and then a proton and a neutron also will have an interactive force of F. There is no change, there is no difference between two forces, between the forces that are existing between a proton neutron and a proton. Okay, now what are the particles that are exchanged in case of nuclear forces? Now the particles that are exchanged in case of nuclear forces are known as gluons. Gluons come from the word glue. Glue means something that sticks to things. So gluons are the exchange particles. What are the exchange particles in case of gravitation? It was graviton. What is the exchange particle in case of electromagnetic force? It was a photon. Now what is the exchange particle in case of a nuclear force? It is actually a gluon. Okay, now in in one of the lectures I have asked you a question, why is it that if I take 1 kg of RDX and if I blow it, what happens? A building could be destroyed. If I take 1 kg of uranium, then that 1 kg of uranium or plutonium could destroy a large city. Now why does it happen? How is it that a 1 kg RDX cannot even destroy a building, but 1 kg of plutonium could destroy an entire city? The answer lies in the nuclear force. In case of RDX, the force is an electromagnetic force. Okay, that is a chemical energy. Electromagnetic forces come in when you are talking about chemical energies. Okay, when you take a battery that has a chemical energy, and what is the force there? Dominant force, electromagnetic force. Now when it comes to the uranium or plutonium, the dominant force is the nuclear force, and nuclear forces are very strong forces. Now when a nucleus breaks, you call it as a fission, and this fission could create a vast amount of energy, and if within a short period of time, if you could create this a large number of fission reactions, then that is what you call it as an atomic bomb. Okay, now when it comes to fusion, what you find is you are squeezing two nucleus together, you are squeezing particles together. Now it is very hard to squeeze particles together. Try to squeeze two iron balls within each other. Now if I try to squeeze an iron ball into another iron ball, two solid iron balls, I have taken two solid iron balls and I want to squeeze one iron ball into the other solid iron ball. There are no holes, I want to squeeze it. Now what is the amount of force that is required to do it? It's a huge amount of force. Now there are only two balls here. Now if I want to squeeze 238 balls, such iron balls, I have taken 238 and I have to squeeze all of them together, then you can imagine the kind of energy that I have to put in. Now whatever amount of energy that I have put in, that I'll again regain when I break it. So therefore a vast amount of energy is used to form a nucleus. So to form a nucleus, I use a vast amount of energy. So when I break the nucleus, what happens? That vast amount of energy also comes back. So that is why the fission reactions are very, very strong reactions. Fusion reactions are very, very strong reactions. Okay, so that is the difference between a normal 1 kg RDX and a 1 kg plutonium. So what are the exchange particles here? The exchange particles are gluons. Okay, these are very short range forces. They arise only when the distance is less than 10 to the power of minus 14 meters. Now the last force, so I have given a simple diagram. Now here meson. Now what do you mean by meson? A meson is actually a gluon. Okay, so meson is a particle that is exchanged between a proton and a neutron. So I have a protons and a neutrons, and these protons and neutrons exist within the nucleus. Okay, so the interaction between these objects, neutron, neutron, proton, proton, is actually a nuclear force. So these particles, they would be exchanging these mesons. This is the exchange of meson taking place here, and that is how you form this. Okay, so radioactivity, nuclear energies like fission, fusion, they all arise because of nuclear forces. Now the last force is the weak force. Now I'll call it as a weak force because it's actually a very weak force. Now the weak force arises within the particle itself. Now we have said that a galaxy is formed by using gravitation. We have said that an atom is formed by using electromagnetic force. We have said that a nuclear force is a nucleus is formed by using a nuclear force. Now how does a particle get formed? A particle gets formed because a single proton is actually a collection of three particles, and these three particles are known as quarks. Now when I move into this proton, what I find that there is another force here called as the weak force. So within the particle there is a weak force, within the nucleus there is a strong force, within the atom there is a Coulombic force. Okay, so within the particle there is a force called as the weak force. This weak force is responsible for conversion of a neutron into a proton. So N is a neutron and P is a proton. Okay, so I could convert neutron into proton, I could also convert proton into neutron. Okay, when I convert neutron into proton, what I'll get is I'll get a proton, I'll get an electron, I'll also get an antineutrino. So this is an antineutrino. Okay, so when we are dealing with particle physics, all these things would come up. Okay, so nucleus could be converted into a proton, electron and a antineutrino. This I'll call it as a beta minus decay. So this is a beta minus decay. Now a proton gets converted into a neutron. Now I have here a positron, I'll call it as a E plus. Now E minus is an electron, E plus is a positron. Okay, so E plus is a positron. So E plus is a positron, and here also there is another particle called as the neutrino. So this is an antineutrino. Antineutrino arises in case of beta minus decay. So this is the beta minus decay, and in case of this neutrino, you call this as a beta plus decay. Beta plus means positron comes out, beta minus means electron comes out. When electron comes out, antineutrino comes with it. When a positron comes out, neutrino comes with it. Okay, here conservation of charge has taken place. Here I have a zero charge initially, finally I have here a positive charge, and I have here a negative charge. So negative plus positive gives me 0. So left side 0, right side 0, conservation of charge has taken place. Now let us, so in beta minus, charge is conserved. Now let us come to beta plus. Now in beta plus, I have plus charge here in the left side. Neutron has a 0 charge, positron has a positive charge. So this is plus 1 and this plus 1. Charge is also conserved in this case. Okay, so the conversion of a neutron into a proton, the conversion of a proton into a neutron arises because of the weak forces. Remember, weak forces always exist within the particle itself. The particle actually does something in order to convert it. Okay, a neutron gets converted into a proton and a proton gets converted into a neutron. Now what are the exchange particles in case of weak forces? Now the exchange particles in case of weak forces are the W and Z bosons. Okay, so the W bosons and Z bosons are the particles that are exchanged between these particles to create the weak force. Remember, force is what? Force is simply an interaction between two bodies. Whenever two bodies interact, you say that force exists between these two bodies, and the fundamental concept is these two bodies interact by exchanging particles. Okay, with this I want to conclude the concept of forces. Thank you.